Okay. Hi, everyone. Thanks for joining us today. We are here with Joe Baguley today to talk about AI's implications on climate, maybe both the positive and the negative. Joe has a really impressive background. He is the CTO of VMware. He's clearly a leader in the IT space. Really excited to be talking with him today on this topic. Joe, would you mind giving us just a little bit of a intro to yourself and your background and what have you?
Yeah, I could do that. So, as you said, I'm the Chief Technology Officer here for Europe, Middle East, and Africa at VMware. I sit as part of the Office of the CTO. Our CTO is a guy named Kit Colbert, based in the US, and I'm essentially his representative and lead the Office of the CTO over here in Europe. At VMware, we're about 2,000, just over 2,000 people in the Office of the CTO, and we work on innovation, next gen products, product strategy, all the kind of things you'd expect the office of a CTO to do. And I've been at VMware now for 11 years. Prior to that, the sort of previous 20 years was I started out as the bilingual secretary to the head of finance and remarketing for Hewlett Packard Europe, and ended up as the CTO of Quest Software just before they were sold to Dell. And there's a lot of stories in that 20 years. I'll tell you some other time.
Oh, I bet. Well, thanks so much. So there's just so much to cover here. I mean, where do we want to start in this conversation? I feel like there's a very broad span of things to talk about.
When you start to mention climate, it's an interesting one, right? So what are we talking about when it comes to climate? And there's some big stuff in the news this week with tech and climate with the Ethereum merge as well. So there's, it's front and center for a lot of us. So it's probably worth starting there, I think.
Yeah, that's great. I know. I was kind of shocked at the level of energy improvement with the proof of stake application with Ethereum. I think that's
it's binary, right? It's like an amazingly huge amount or next to nothing. It's almost huge, the difference between proof of stake and proof of work. And I think Bitcoin's got a lot to look at and answer for in that respect. So yeah, I think when you look at a lot of these things, when we talk about AI as a concept, AI is in its very essence, at the core, AI and machine learning is about huge things, huge data sets, huge computation actions, huge this, huge that. And all of those have huge implications in terms of energy. So I don't think there's many, like the founders of Bitcoin did not think when they were writing Bitcoin, let's think about the energy consumption of this as a concept, right? That never came up, right? So I'm not sure there's all that many coders, full stop, developers, anyone, particularly not in the AI space or the data space or anything like that, that when they come up with the new concept of a new way to, for example, build 5-stage neural networks quicker, they go, oh, I wonder what the energy implication of that is. I don't think that happens.
Interestingly, I saw like the Allen Institute did a research project. It was a couple years ago now, but they estimated that only 10 to 20% of AI research even gives any homage to the energy conservations of their algorithms that they're developing, right? It's just hyper focus on accuracy. And it's interesting to motivate. How do we motivate people to even do that level? Even Bitcoin, to your point, do you think that's going to catch? Do you think that Bitcoin is going to answer to it? Or do you think they're going to keep doing business as usual?
Well, I think that, so that you've always had these two, right? You've had Ethereum. Bitcoin was first, then Ethereum was always the second, but it was always a decent alternative. But the problem is they were both bad because they were both, proof of work, and they were both, terrible for energy. So people could just put it in the big bucket of crypto's bad for the environment, go away, right? Now you've got one of the two big players is we're not bad for the environment, we're proof of stake. We're, negligible in that context in the grand scheme of things. And so I'm wondering whether that's enough to draw people across to that. Or whether it's, enough that Bitcoin's just going to go, well, I don't care, carry on. We're doing really well. We're fine. The other interesting thing is, especially from an AI perspective, from an ML perspective anyway, right? So that there's a bunch of GPUs out there now that were being used for Ethereum mining that are now going cheap.
Well, having said that, a lot of Ethereum miners have basically said, yeah, we've spent the money. We're literally going to switch to Bitcoin.
Exactly. That's the thing, right? So some people are selling off the GPUs, whatever, right? But most of them are just going to go, right, we'll go do Bitcoin. I don't know if their mining rigs actually make economic sense to do Bitcoin, but maybe they do, maybe they don't. And that's the point, some of them might not be at the breaking point where it makes sense to switch into Bitcoin because then, but yeah, so that's, it's that great question. Now we've done that. Has it solved the problem really? Or are they just doing something else?
Right.
That was an interesting one.
Yeah. And I thought that and maybe it'd be helpful just to talk for a minute about the actual numbers, because I think it's pretty shocking when you even have any purview into this. And I'm not sure how widely people have purview into the implications of consumption with Bitcoin, right? Oh. And it's huge, right?
It's absolutely massive. There's a thing called the Bitcoin Energy Consumption Index. If you go to digeconomist.net, okay, and if you go and look on there, it shows you the carbon footprint of Bitcoin. Now, there's arguments to and for this, and we can get into a great bit of detail, but in most essences, most people, consensus agrees on the figures on the Digeconomist piece. So a single Bitcoin transaction is 774 kilos of CO2. Now, that's a meaningless number to most people because they don't constantly, it doesn't mean anything, right? But if I tell you that's the equivalent of 130,000 hours of watching of YouTube for one Bitcoin transaction, or 1.7 million Visa transactions, or the equivalent of running an average US household, which are the worst in the world, for 47.81 days, right? Or from an electronic waste perspective, as in the e-waste that's involved in that transaction in terms of the silicon that's being used that gets burnt, all these miners going through, et cetera, it's basically equivalent of 2.5 iPhone 12s, right, for each Bitcoin transaction. So it's 2.5 iPhone 12s worth of e-waste, physical e-waste, for one Bitcoin transaction. The total energy consumption, this is the bit that gets really scary. The total carbon consumption, the energy consumption, right? So the actual energy consumption of Bitcoin annually is the same as Norway, the country.
It's
Norway.
Phenomenal. It's horrible.
Isn't that, it's just like, what? So we have a whole country's worth of power. And that's Norway, right? That's not a small country. There's 129 terawatt hours, right? It's a huge country. Doing some amazing things, and you imagine all the heavy industry that they've got and all the stuff they're doing in Norway. And Norway's also a leader in electric cars, so they're probably the most number of electric cars in the world, so they've got a large consumption of energy from electricity in that context as well. Anyway, it's the electronic waste is the equivalent of the Netherlands. It's like, oh my god! So people just don't realize it's Bitcoin. It's just a thing. We don't think about it, But yeah. It's horrendous. So you start to land it in those figures, scary.
Yeah. Well, and then in some of the things I've seen, it's not only Bitcoin, even some of, some very commonly used AI algorithms are astonishingly energy grubbers, right? I saw a statistic about BERT, natural language processing, and training that once with some amount of data is similar to a trans-American flight, right? So those little things I don't think developers typically think about when they're actually applying these methods.
Well, no, and I think if you look at it, some of the stats you can pull up very quickly on that as well. And I spent some time in the early part of this century working on the Code of Conduct for the European Code of Conduct for data centers on behalf of the British Computer Society, and helped lay out that when we were looking at early days of. And trust me, 20 years ago, IT equipment was terrible in data centers. There were non-linear power supplies, so it was the same power usage if you were fully maxed on the CPU as if it was idling. It was much different. We've got a lot better at that now. But still, a single V100 GPU can consume somewhere between 250 and 300 watts, right? So if you assume, 250 watts, then 512 of those GPUs consumes 128 kilowatts, right? So, run that for 9 days, that's 27,000 kilowatt hours, right? The average household uses 10,000 a year. Right. So you go and run some, so for example, that comes from OpenAI stats. So OpenAI trained its GPT-3 model on 45 terabytes of data, right? And to train the final version of Megatron LM, which is a language model similar to GPT-3, NVIDIA ran these 500 GPUs for 9 days. And just to do that, to train that model took the same as 2.5 houses.
Yeah.
Right.
Insane.
Whoa. Right. And they didn't turn those GPUs off at the end. They went off and did something else with them, right? And something else. So this is where it gets interesting, because when we were doing the whole energy consumption stuff in data centers, which I'm not going to go into detail here, but we got to this problem of how do you talk about useful work, right? So I'm okay, I suppose, in blowing tons of energy on machine learning algorithms around cancer research, who's going to say no to that, right? Crack on, right? And we did it folding at home and all these other wonderful things. We during the pandemic, folding at home was being used for some of the essentially the antivirus research and the vaccine research. And we brought out because we just said, okay, fine, if you've got spare VMware capacity, we're going to bring out a VMware machine. Basically, you can spin it up and it automatically fires up and uses your spare CPUs towards solving COVID. Yeah, fine, crack on. I think it's a brilliant idea, but there's other activities that maybe aren't quite so clear cut.
Yeah, for sure.
But that's when you're asking the engineers and the data scientists to make ethical calls of environment versus and as you say, some are clear cut. Cancer, COVID. It's the ethical stance there, really fairly simple. Actually, I say that and second guess myself, because I remember during COVID, there were protests saying you're focusing on this and climate change is a real emergency. There are people who would say, no, it's not worth using the compute and the damage to the environment, even for this. There are other uses of compute which most people will have no problem saying it's not worth the environment for. But virtually everything comes in that grey area of balancing, depending on where your philosophical stance sits.
Yeah, the climate change one's a really interesting one. So Carl Sagan gave a speech in 1990. You'll find it online somewhere. It's fabulous because he talks about the total spend on military spending in the US from 1945 to 1990, when he gave the speech, towards military Cold War activity was $10 trillion.
Oh my gosh, yeah.
Right? And he said for $10 trillion, you could buy everything in America, full stop, everything in America, apart from the land, right? Everything, every house, dog, car, cat, you name it. You could buy the whole lot for $10 trillion back in 1990. And he said they did that. He said, now, was Russia invading a certainty? Well, clearly it wasn't, because they didn't, right? But was it a 10% chance? Was it a 20% chance? But somehow with that 10% or 20% chance, they were still willing to invest $10 trillion into it in the military industrial complex. Yet, with the same levels of is climate change certainty, we didn't invest $10 trillion in doing that, right? So I think to your point, it's really interesting that it's, we can wax lyrical about ethics here for a long time, but it's that prioritization in people's minds, right? And back in 1990, people didn't care about climate change. Now, is it different now? Do they? Really?
I don't know. Well, and I guess one of my questions is, even if the right people did, and I think certain people do, right? There's very influential people that do, but what kind of regulations can even be driven or put in place to support that direction, right? To motivate Bitcoin to actually move in that direction, or other companies, like there's a lot of elements to this. We couldn't go into all of them, but this specific one, is there an opportunity for regulation?
Yeah, there is. So, there is the opportunity for governments to not use Bitcoin and use Ethereum instead, for example. So El Salvador became the official currency of El Salvador, became Bitcoin, right? In earlier this year, I think it was actually last September. So that's not exactly great, is it? Thanks, El Salvador. You just essentially endorsed something that's using the same amount of energy as Norway. Good call, right? Could you have chosen Ethereum instead? Probably, and so some of the conversations I've had with governments, articles I've written, and conversations I've had with ministers, it's been around the fact that, cryptocurrencies are great. Cryptocurrencies are going to be a thing. There's no doubt about digital currency. Let's call it digital currency rather than cryptocurrency. It sounds a bit better. So digital currency is a thing. But can you at least make sure that when you go into the future of digital currency, you listen to people like us about the energy impact and environmental impact of the decisions that you make? And choosing one that's proof of work is going to be a bad thing, and proof of stake is a good thing. It's very fundamentally different. So no, they might not be able to regulate and say proof of work is illegal, but if you start saying that your default is not that, then you can lead by example. You can hope, right? That's my wish.
Yeah.
Well, we've also had certain European nations start to put rules around data center expansion and where you're allowed to build, where you're not allowed to build, because of the capacity there, which isn't regulating the use of it, but it does have that knock-on effect that if you literally can't build the data center support, you have to start thinking about other ways to build.
Yeah, we had that actually probably a few years ago, a bit longer than probably in the sort of 15 years ago. There was a bit of a competition between some countries around the world. I won't name any, but some of them were in Europe, where certain hyperscalers were building data centers in those particular countries because those particular countries didn't have a requirement for energy usage and climate impact reporting of data centers, right, above a certain size. And so, you know, it's that you end up to that whole, okay, fine, well, should it be a standard that every data center globally has to report its consumption in a particular way? Then you're always going to find people differentiating. So, well, come and build in our country because we will make you report on that kind of stuff, and you can do what you want, you know. So it's the whole free zones or whatever it is. So it's a competitive advantage some countries will see in that by going, oh, we can attract them over here. But then you go, well, actually, that's not even going to matter, because if you're not going to, and that's the other thing. So probably 10, 15 years ago, corporate buyers weren't bothered.
Yeah.
You know, didn't care. Now they care. Now they have ESG pipeline management. You know, they look at their sustainability pipeline management. They look at their scope 3. They look at all these other wonderful things. And it's like, do you know what? No, I can't do that. We can't buy from you because your sustainability doesn't work that way. I think we were talking about the difference. I think the real difference is exactly that. So, you know, 15 years ago, corporate buyers didn't care about where their cloud ran, right? It didn't matter. It was just get on. It's cheap. It's great. It's fantastic. Now you have to differentiate as a cloud provider, as someone that is, you know, working with renewables in a sustainable way, can prove the scope 3 part of their sustainability, you know, pipeline reporting. That's really important. So now it has become important. And that's what, to an extent, that's what I suppose self-regulation has done to the industry.
Yeah, and it's interesting you say that, because it feels like so, well, my experience as a data scientist developer for, you know, a couple decades, I honestly didn't like, I feel removed from that, even when we started getting more on the cloud and everything I was building, or my teams were building, was getting put on the cloud. There's this layer of obfuscation, right? Where, you know, it wasn't even focused, because to your point, to the consumer, it's very cheap. I might as well spin up, you know, 100 nodes because it's going to make this thing run faster or at all. And it didn't have, there was no like focus on it, you know. And to your point, there's the main ways we make models better is, you know, there's 3 primary ways, right? You increase the data, you make the model more complex, or you increase the number of experimentation, right? For hyperparameterization, right? All of that's like pretty expensive stuff. And to a point that it's not linearly related to accuracy, right? So a lot of teams have this hyper focus on accuracy while just piling on the compute resources without really any accountability at all. Maybe the cloud providers have this level of accountability, but from my experience from the developers, there's almost no accountability or even a lot of foresight, it seems.
Is there some kind of diminishing returns game in that, do you think?
Totally. Yeah. I mean, like, it's basically a logarithmic graph, right? So you have like really good gains at first, and then, you know, 10 iterations later, maybe you're only getting, you know, 2% more accurate, or very small gains, right? And oftentimes in a business context, that means very little, right? You have to start questioning, like, how are we even using this output? Is it useful to be that much more accurate? And I don't think that's questioned enough. Like, I think everyone just has such a hyper focus on accuracy that it's not even debated, really. It's like, let's just get it more accurate, even if it doesn't have impactful business ROI.
Yes, there's a thing about some is good, more must be better, that people just keep going, as opposed to saying, actually, good enough is good enough. And what good enough looks like might be different when we were talking about the different purposes. Yeah. But that's never discussed.
But as you know, obviously I sit here in my ivory tower of CTO-ness. I don't get involved in this, but so in the level of detail. So as an AI developer, I suppose my question would be: are these costs exposed to you?
No, oftentimes not at all. Like, maybe if you're a leader of a team, they are to an extent, but it's more like a budget, right? And if you're then thrown into these ROI conversations, and a lot of times the benefit of AI is very high, And when you're looking at the cheap cost of cloud, that's, that ends up being the conversation that you're in. And also, just because of the nature of AI applications in business, it's not easy to talk about how to use the results always, how to implement it into your business. So it's a lot easier for a data scientist to talk about accuracy, to hang their accolades on. And so,
they can't talk about business outcomes, so let's talk about how accurate our data is.
Exactly, yeah. Yeah.
And also, as a justification, there is a fear around AI. Accuracy is often used as a way to appease people, to say, don't worry, it's not scary, look how accurate we are.
Yeah. No, I get that, and it's a really interesting. I've never had that conversation before around the accuracy side of things. It's never really occurred to me, because it's kind of, we like to think that in the cloud world we're exposing cost anyway, because obviously there's nothing more. If you go back to pre-cloud, people had stuff in data centers, and the funny thing was the data center energy bill was never paid by anyone in IT. It was paid by someone from the buildings department. So the people in IT never even cared about energy consumption. Right? It was just, oh, can we just put some more computers in there? Yeah, fine. That was it. And then as cloud comes along, because people are then running it as a business, they have to be very careful about the costs, and they can then work out, if I'm renting this much, then I have to know the margin, blah blah blah. So it starts going on, and that means you start exposing the cost through the system a bit more effectively, and so the energy costs do become a factor in the cost of the resource that's consumed. And what's nice from my perspective is that clean energy sources are now becoming cheaper than dirty ones, so that's kind of cool, and actually will force a motion in the end. But the worrying thing is, all that's brilliant until none of that cost is exposed to the person actually making the decision on how many things they're using, right?
Totally, yeah.
And that's kind of, is there an opportunity here? Is there somewhere you could have like some kind of decision map where you're just assigning costs to things? It's like, okay, fine. If you want to run it this accurate, it's going to cost you this much. And if you want to run it that accurate, it's going to, these 3 paths will cost you this, and blah, blah, blah. Is there some, AI modeling cost planning thing?
Yeah, and I think, to me, the most progressive way to do that is actually, and I know we have a lot of advances in this arena where you're making more and more algorithms like lower down on the stack, right? So more in the hardware. And then you basically encourage the use of those optimized algorithms. That's probably the easiest path forward, because of course there's the gap, and it would be nice if people had that visibility, but I'm just not sure how much that's going to be emphasized given the price tag, right? Most corporations who are using AI, the cloud cost isn't really a huge concern for them. And so that to me seems like probably the thing that's going to affect developers the most, because it's going to have, unfortunately, it ends up not even being about motivation for green. It being motivation for fast training, fast tuning, which is a byproduct of bringing those algorithms lower down into the stack. And I hate to say that, but that's unfortunately how most data scientists are motivated. They want it to be faster without having to compromise their accuracy.
Yeah, so I mean, I think that's worth looking into. How do you achieve faster? And then what does faster look like in a more cost efficient, more energy efficient way, if you know what I mean? Because classic faster in IT has been bigger, right? Let's just get a bigger, newer CPU, right? And let's get a bigger, newer GPU and DPU and all these different things. Let's go to specialist hardware and get this, because that'll be faster, and so on and so forth, without thinking about the long-term impact of that. Or maybe we should be engineering for a different faster.
Yeah, I think so. Or like even the idea of proof of stake, it's really just a different way of executing, right? And I think there's probably room for that within the more classical AI methods we use, and like kind of going that direction for optimization of.
Yeah, the optimization piece is important, right? So how do you optimize, because I was always told, I remember my computer science degree days, which I didn't finish, by the way, but for the short 2 years that I was allowed to exist at Imperial College, I remember going in with code, and then my professor going, yeah, it works, but it's not elegant. Do you remember that? It's like, yeah, you've written in 15 lines and I could do it in 3. You're like, oh God, okay, fine. And actually when you understand it, I think, and I've taken that forward in my whole life of IT, basically. And when I went to architecture, everything, and systems architecture, system design, it's always like, okay, well, it works, but is it elegant?
Yeah.
I would ask myself that question. And I wonder how often people ask themselves that question when coding in that way, because the elegant is usually the most efficient.
Totally. Yeah. And yeah, I mean, and I don't want to go so far as to say it's not questioned at all. I think it is, but I think, and it goes back to what I was saying about research in AI, like almost none of it really looks at optimization efficiency of the compute. Like when people are innovating new techniques, that's not the focus. The focus is how do you make it more complicated, but it goes above and beyond that, where we could be innovating new training procedures, right? There's new procedures you could run through for the very expensive training and tuning events that we do. But there's just not focus there. There's not motivation there broadly. I mean, not exclusively. I mean, clearly some people are working in that direction, but it's just not by and large the biggest motivator.
Is this because it's a 10x problem? I do hear the 10x problem, right? Which is, I'm not interested if it's 10% faster, but I'm interested if it's 10 times faster, right? That kind of thing. If it's 5 times faster and half the price, that's 10x for me. It's those kind of things. Is it because we're not making 10x leaps that we're not going down these roads and people aren't interested? It's like, well, actually, if you ran it over here, it would be 10% faster and more energy efficient. People are like, whatever.
Yeah, I don't know. It could be. I'm not sure. I think there must also be some element of like just demand, because data scientists that build ML and AI algorithms are in such high demand, and that's really not what they're being paid to do. They're being paid to build things that are good for the business. And not that that's not good for the business, but that's just not quite how the business often looks at it. I don't think that's my impression based on the clients that we've been with. And yeah.
The comment you made earlier about the budget for these things coming out of different people view these things as a cost center, and exactly how the cost center breaks down, people don't look at in the same way. This is how much everything costs.
Mm-hmm.
This is the output. It's not, this is why this costs this much. It's like, well, this is what compute costs. There are things where you can do shifting times of day that you run the training to, because depending on where the compute is, depending on the time, it's more energy efficient. No one looks into it because they don't.
So is there an ESG-led marketing opportunity here, right? So along those lines, where we go, okay, fine. Well, actually, your AI might be the same as my AI, but my AI is better from an ESG perspective. Literally, they both get the same result at the same time, right, for the same cost. But this one's better from an ESG perspective in terms of sustainability, in terms of social good, in terms of environmental, all that kind of stuff. Is there, there's got to be legs in that, hasn't there, somehow?
We're starting to see that, but let's face it, the good stuff, be it ESG, be it ethics, be it any of that, everyone says they care, and then when you look what they vote with their feet, no one cares as much as they say they do. It's starting, it's improving, but we've had CSR forever and nobody really cared. ESG is CSR grown up. But again, people are starting to care, but until customers reflect it, I don't think it's going to hit the business bottom line. And until it hits the business bottom line, they're not going to pass it down.
So how can we use AI? So we're talking about AI's effect on climate here in terms of, how much it uses AI, all those kind of things. What are the ways that you're seeing, I'm sorry, I'm interviewing you now, but what are the ways that you're seeing AI help with climate change in a way? What are the visionary ways that we could do things in that space? I think that's where it's more exciting, and to a point where, come back to our original, earlier discussion, you wouldn't care about it because it's like, oh my God, it's solving that problem. Is there any ways you've seen around?
Yeah, I think in the business space, at least, the most common place you see that is where it's linked to optimizing cost. So like, optimizing operations or manufacturing lines, optimizing your processes, like how often you're using machines, how long it takes to do things. That's where I see it the most in the business world, is some sense of optimizing cost, because they have a visceral attachment to that, right? And so it's motivation. And so I think that, and then there's the very direct things, which honestly I don't have at this point in my life very much connection to or like experience with, but it's like reducing deforestation or managing forest fires. I know there's a lot of research in that direction of almost direct, application to helping actually really more manage the effects of climate change, not necessarily,
yeah, a lot of it's the effect stuff. I saw some great research recently from people doing, using AI on satellite imagery to help farmers plan what they're doing and where they're planting and stuff like that. Those are the kind of things where it's okay, that's actually going to make a difference. But that's really responding to the fact that their environment is being destroyed, as opposed to how they can save the environment. So yeah, we're using AI to deal with the symptoms, but maybe there's some better ways we could be using AI to deal with the cause as well.
Yeah, definitely. Well, and it's interesting because I think, sadly, and maybe this is a narrow view, but it feels like the way to use AI to improve climate change, like we know it, we can move in that direction. It's just the motivation to get there, I think, right? Because it really does often distill down to the carbon footprint.
Mm-hmm.
And we have ideas how to do that. And I think AI is used in that direction in various different ways, but it's about the finances behind it, I think.
And often you see smart things being touted as a way to save energy, but we know that behind them, it's actually the resources. It's just not on your front door. It's still just as resource heavy. It's just not there where you're seeing it. And yes, you do see people pushing like, oh, well, if you do this, like, yeah, that's just moving the consumption out of your sight.
Right. Well, and I think when you think about broadly the application of AI to support or in the direction of how it affects climate change, not only in terms of consumption, but these other elements that we're talking about, there's probably as many that do harm, right? Because oil and gas companies use it to help optimize their drilling. They help the extraction processes. They, a lot of the things that a very direct byproduct of harm to the climate too. And I don't know what that balance is. Hopefully there's more in the direction of supporting, decreasing the effects of climate change. But
yeah, you can sit there and think of, I say, when you started talking about smart things, you start thinking, you think smart homes, you think actually we could start to improve instrumenting homes and using AI to start planning how energy management goes on better in homes, so people heat their homes more intelligently to lower their energy bill costs and therefore environmental. But there's some cool stuff that's going to go on there. But I think what's great is that's now going to be driven by cost. It was a really interesting, a conversation I was in on Twitter the other day where I was in a conversation with a bunch of other people based in the UK around solar panels and batteries, because I've got solar panels and batteries and other stuff. And I was having some other of my tech friends going, asking me loads of questions about which solar panels to get, whatever. And then there's a question in there came in from someone in our space that's in Kuala Lumpur going, does this stuff really, make financial sense for you? I don't understand why, it's very expensive. And I went and had a look, and Kuala Lumpur's energy price is about a quarter to an eighth of what ours is in the UK. And I'm like, okay, well, if your energy price was like ours, it would make financial sense to do solar panels and batteries, right? So I think, the energy crisis that we're in now will improve demand for people to get more energy efficient around what they're doing. So hopefully more people start to put smart stuff in their houses and get a bit more intelligent about things, and start to put Hive and Nest and other things around, just trying to, as a way to save money. I think that's going to be it. I mean, I'm not quite telling you all to buy a new kettle as Mr. Johnson did, but there's ways you could do that to save dramatic amounts of money. So and that's there's some really cool stuff we could do with AI, I think, in that context. But it's getting those AI models that make sense across all those different environments. It's going to be fun.
Oh yeah. And again, I think it's not. I think our sophistication of solutions in that direction is beyond the motivation. And I don't mean people's passion about climate necessarily, but even just financial motivation, like you say. Like I know here in the US, people often don't do things like that because it's expensive, to like implement those things. And it's very hard to measure the benefit. And you do it because for your own reasons, maybe you have enough money for the startup of that and you can see the long-term, benefits. But for a lot of people, that's not how they can even operate, because they're not in a financial situation where that's even possible.
So that's interesting on a slightly more meta basis, because take that back to business and just AI, forget the climate bit, but business and AI. there's a lot of businesses right now that can't afford AI because it's expensive. It's like solar panels, right? It's like batteries on your house. But I believe they will come to a tipping point where they can't afford not to. But at the same time, these AI services, etc., should come down in price at the same. It's the whole standard economic model thing. I think that's exciting, isn't it?
Very. And actually, that's one of the things we focus on here is more like how can we bring ML to people in a more economic way by taking on some of the burden of those things that make it very expensive.
I was going to say, but back to the original conversation, it's like air travel. As you democratize it and more people use it, the volume starts to hit again, and then we're right back on the circle.
It's called Jevin's paradox. Is the official term for that. There's a guy called William Stanley Jevons in the 1800s. I know it's from Cloud Camp and Simon Wardley and some friends of mine. We all talked about Jevons exactly this concept because it is that problem. Someone back in the 1800s pricing and simplifying it, but basically said if we make a more efficient steam engine, we'll use less coal as a nation. And it was like, well, no, actually what happened was we made a more efficient steam engine. Steam engines got cheaper to use. Therefore, people found more ways to use steam engines and and here we are. We've got coal everywhere and everyone's using steam engines. People are putting steam engines on wheels and dragging people behind them. It's that kind of thing. Whereas before they just sat there. And, it was the same with cloud. It was like, oh, well, cloud's more efficient, so therefore we're going to use less energy. It's like, no, more people are going to find more ways to use compute to do more things because it's cheap and it's easy and it's just going to go mad. So you're exactly on the money, spot on. That's exactly it. I mean, that's the challenge. So that comes back to the original point, right? It's like Bitcoin. Yeah. We have to be really, really careful as we go forward in these models that what we're encouraging the commoditization of, we're aware of Jevons paradox in our mind to say, okay, fine, if this does go to billions and trillions in terms of consumption endpoints and running executed models, et cetera, is that okay? And I think that's really, and that, first of all, we have people writing stuff that don't even care about how much it uses in the first place, let alone think about the long-term consequences of possibly it going global.
Yeah, and I think that makes me start to think about a point you brought up earlier, Joe, around the different motivations for AI, right? So you think about comparing, even in a business context, you compare an AI that reduces energy consumption in a manufacturing line, for example, versus the energy consumption of a recommender system, right? So in the recommender system, there's lots of good things for the business because you're increasing revenue, right? But there's also all these downstream implications. Not only is it incredibly expensive, but it has you're creating more.
It's increasing consumption,
right? Exactly. Yeah.
Well, we know my heart is in privacy, and the energy consumption of ad tech and the AI in ad tech is unreal. If you think about the biggest consumers, the mega tech firms, and how much of that consumption is due to the ad tech they operate on, then the ethics of that, well, we know what my opinion is going to be.
No, please do tell.
Yes. And so we can't justify it ethically. And it is an unreal consumer of energy.
Yeah, it's a worry, really, and let's say you're never going to answer it in a podcast as to what the ethical answer to this is, but I think it's one of those dilemmas we're all going to have to play with.
Yeah, and do you think this is true? My perception of companies who are trying to go green, like Google, and it seems like a lot of that direction is towards focusing more on renewable energies. And I don't hear as much on the optimization of how much compute you're actually using or driving in that direction. But maybe what's your opinion on that? Do you think that's a true?
Well, let me answer it in a slightly different way, and not in a politician way, but a slightly different way, because there was something I've talked about before, is whenever I've challenged people about Bitcoin publicly in articles and stuff, they're going, oh yeah, but we're doing Bitcoin mining on renewables. I'm going, well, okay, so that's interesting. I'm not going to say that's great. That's interesting, but those renewables could have been used for something else.
Right.
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 So those solar panels that were made and those hydro power stations and those wind turbines, we could be using them for something else that's not Bitcoin.
Right.
So I still don't quite get it. It's like, okay, brilliant. So you're wasting resources that we use to make those things that do renewable stuff.
Right. Yeah.
Right. But
Yeah.
it's renewable, so it must be fine. It's like, no, I just don't. So yeah, you could. And that applies back to what you were just saying, I suppose, to an extent, right? It's okay, and that comes down to the ethical piece of useful work, right? We're putting renewable energy into this. Is this useful work? What defines useful work? Yada yada yada. And we end up in this sort of same circle again. I think that's the challenge. Is just because someone's using renewables or is carbon neutral, does that mean that there's other industries that are more deserving that could be carbon neutral that aren't, because the renewable on the grid is being used by the non or less ethical or whatever you want to call it, the different people, right?
Yeah. Well, and it's almost like a utopian thing in my mind when I consider it that way, that we as humans would apply that, which seems so logical to me. It's like, that seems so reasonable. It would be interesting. It's also hard for me to imagine how it would be executed, where you're actually distributing energy based on that.
Price it differently. Charge different prices. There you are. Oh, you're doing that, right? That costs this much to come off our grid. Well, you're doing the good stuff. Okay, that's the cheap energy, maybe. Yeah. But then does that drive them down okay, well, if you're doing the good stuff, you don't have to be very efficient at it because you get it cheap.
Exactly.
Oh, this is a nightmare.
I was going to say, we also know that what people consider good and polluting, etc., changes. I mean, Both in the UK, there was this whole thing where everyone was told to get diesel cars because it's much better. And then they've all gone, no, diesel bad. You need to come off diesel again. And that was in a short period of time where the attitude on what the worst for the environment was completely 180'd, completely changed around. So as we say, if we try and price things differently, because I think we've all agreed most people are motivated by money. Or at least the organizations are, and they're actually running a lot of it. Even the advice they're working on changes.
Well, that's science. I think that's the point. That's science. That's what science is. It's not empirical. It's not fixed in stone. That's the whole great thing. That's why we all love what we do, right? Because it does change every day, and someone can turn up with some better evidence and a whole new bunch of stuff, and you go, wow, that's amazing. We should be doing, that's what gets me going all the time, is that stuff that I was taught at school has now been disproven. How cool is that, right? Because we moved on. So I think it's being acceptance of that change. The hard challenge we have is that people aren't accepting of change. They go, oh, no, we've always done it this way, and that's how I've always done it, so I'm not going to change it, and it's worked for me. That's the problem, right? So yeah, I'm glad I'm not a politician, is all I can say.
Well, I'm with you on that one. It's a little bit nicer to stay in the science world where you can sort of think about the possibilities a little bit more freely.
Well, so we're heading towards a really interesting future, right? I was actually chatting to someone from literally the meeting before this call was with the head of innovation for one of the major car companies in the world. Really fascinating to talk to, but the way he was talking about it was, we're planning for stuff in 2035. I've got stuff already in pipeline for 2030. That's the timelines they work on. Whereas I said in my tech world, my 2030 is just a big fuzzy thing in the distance with 6G written on it. It's kind of like this interesting way that we look at what's going on. But when we do look at that future and I think about that, I get quite excited. But then in the light of the conversation that we've just had, I get concerned, because when I look at what's happening in the future, when you look at 6G is really the sort of concept that as you've gone through 3G, 4G, and 5G, telcos have become more like cloud companies and how they've had to operate, build the networks, et cetera, et cetera. And so right now you've got a cloud company over here and you've got a telco over here, and they're very separate things, Vodafone, Amazon, whatever, right? Come 6G, it's going to be the same thing. They'll be fighting out. You won't be able to tell the difference between a cloud company and a telco company. And so because they'll be, ubiquitous in what we do and they'll be integrated. That's number one, confusing. But number two is where that stuff's going to happen. A lot of it's going to happen in space. And so you're seeing an awful lot of stuff being thrown into space right now. So you think of Starlink, you think of LEO Web, and all of them. It's all these low Earth orbit communications networks. You're starting to see the first signs of that. iPhone 14, which is out today when we're recording this, that's got the ability to make an emergency text to a satellite, which is already behind the times because T-Mobile have announced with Starlink in the US that you can use 5G to make calls to satellites from your phone in the new plan with what they're going to do, right? So, you know, what we're heading towards is a ubiquity of connectivity. So, and that's kind of underpinning what's happening with 6G. So everything's going to be everywhere and everything's going to be connected. Now, when I can start connecting more things, what's that going to do in terms of all of this stuff, right? Because we're doubtless going to have more devices out there. So that's more electronics, more e-waste, more all that kind of stuff. They're going to consume more energy. So we're not going to put less things out there. We're going to put more things out there consuming more power. A lot of them are going to be battery powered. So there's going to be more batteries involved. And there's a whole separate podcast to do about battery tech and so on and so forth. So I think that the point I'm making here is that no matter what we do as we go forward in this, we have a responsibility to make sure that what we are doing going forward is as efficient as possible, has been thought through to the extent that we possibly can about the large scale impact of anything we're doing being suddenly on 1 billion devices or 1 trillion endpoints or whatever that is, and how that works. And you're building that, and it's something I talk about a lot internally to our developers, is when you're developing that thing, what if it has to develop with what if it has to deal with 1 trillion things talking to it? How does it cope? What does it do? And, you know, when you do that, are you building things that scale in a economical way or scale in a linear way or however it works? And that comes back to elegant architecture, etc. So there is a fundamental here that we are not going to stop having more things. We're not going to stop having more data, more endpoints, more everything else. So we need to think about it now. I mean, it sounds like some kind of massive, you know, speech to the masses, but it's kind of this is something I think about quite a lot.
Yeah, and I mean that's brilliant. I think that if people like, if I think about the possibility of if in a magical world all developers encapsulated that thinking, the change that would occur, right? In terms of okay, how are you effectively scaling? That would have so much effect. Just that it sounds small. It kind of is small.
Well, you know, we have privacy by design, we have security by design. Why not have ESG by design?
Yeah. Or scalability by design. I mean,
scalability by design. Yeah.
And ESG built in, right? You know, scalability by design, ESG built in. You know, we thought about this. We tick these boxes. When we designed the system, we realized that if it ever does scale to the fact that we're running it on the moon, then this is how it's going to work. You know, I think that's really important. I was actually at a conference recently where I had to sit on stage and discuss running tech on Mars and the moon and things. And that's a whole different game entirely. But yeah, you have to think about that. There, you care about power consumption because you haven't got a lot of it. So, you know, and it's a really interesting actually. It's like going back to basics when you do that, and that's forcing a lot of developers to almost revisit the 60s in terms of how they thought. So, you know, yeah, I think maybe we started something here. Maybe that's what we're doing.
Well, that would be great. Yeah. I think in my world it's interesting because I think developers in the data science, AI, ML world, I mean, I'm just continuing to think about the downstream effects of adopting that scalability by design, right? And I don't mean scalability by design in terms of parallelizing everything where really you're not reducing much of the compute power, but rather optimizing the consumption. So that's exciting. And maybe, you know, I certainly want to adapt that and spread that with the small circle of people that I influence.
Let's do that then. Let's make a pact right here, right now. That's what we'll do.
I love it. Yes, cool. The pact is here.
All for it. Absolutely.
Great. Well, I think we're about up on time. Really appreciate your time today, Joe. What a great conversation.
Been fun.
Yeah, right.
Really
and
fun.
Hopefully we started something. Sounds like a good pact. Maybe our listeners can make the same pact.
I'll keep watching out for my next interviews all being interrupted by the energy companies again or something. So, I'll watch my back now.
They're on to you.
Yeah.
Brilliant.
Well, thanks everyone. Thank you, Joe. Thanks everyone for listening. If you're interested, you like this podcast, please click the link here and subscribe to our newsletters, and which you will automatically be able to see all of our future and past podcasts. Appreciate everyone listening.